suppose we want to prove that if it's January and you're in Alaska, there's going to be snow. And suppose we know some things. We know that there's snow when it's cold. We know that if it's winter and you're near the pole, it's going to be cold. We know that if you're in Alaska, then you're in the northern hemisphere and you're near the pole. And we know that if it's January in the northern hemisphere, it's going to be winter. So these seem relevant facts, but if we try to move forward and show that there's actually snow, we find that we can't. We can't get off the ground here. We don't have enough premises. And that's as it should be, of course, because there isn't snow everywhere all the time. There are some places where it pretty much never snows. And in fact, even in Alaska, there are times when there mostly isn't snow. So we ought not be able to conclude snow. We want to conclude January in Alaska, there's snow. So what can we do? And what we're going to do is to use a special kind of inference rule that's going to let us do that. We're going to take these premises, assume January in Alaska, and see what we can do. And the rule that we're going to use is called the conditionalization rule. It's a little different from the other rules. It says that if we start with a set of premises, call it A, and we add something else, some additional assumption, call it P, and those two together entail some conclusion Q, then what we're allowed to conclude is not Q all by itself, but that P implies Q. Now obviously it's really P and A imply Q, but remember that we never assert explicitly our premises. That's taken in the background. So we have that P implies Q. All right, so now let's see if we can make that happen. Here are the things that we're told. Let's add that it's January and Alaska. And what's our justification for that? We're going to treat it like a premise, but it isn't a normal premise because we haven't been told it. It's what we're going to call a conditional premise. Think of it as, assume that it were true that it's January and Alaska, and let's see where that gets us. So let's see where it gets us. The first thing we're going to do is pull it apart into two pieces so that we can use them separately. So using the simplification rule we have, well, it's January and it's Alaska. All right, what can we do next? Well, if it's Alaska, then we're in the northern hemisphere and we're near the pole using modus ponens. So let's go ahead and assert that. And then we can pull those two apart, again using simplification. We know that you're in the northern hemisphere. We know that you're near the pole. So we've got those two facts that we can now use however we like. And so we can put the January assertion and the northern hemisphere assertion together, since we know both of them. And with that, we're going to be able to use modus ponens with January and northern hemisphere to derive winter. This is progress. Now what we can do is put winter together with the fact that we're near the pole. And with those two together, we're going to be able to use to and modus ponens and conclude cold. Good, we're almost there. Now we can use cold and modus ponens and derive snow. What have we got? Have we proved snow? No. What we've proved is that January and Alaska imply snow. So let's write that down. And the justification for that is that we used the discharge part of the conditionalization rule. We combined the conclusion snow with the assumption that we made all the way back up there to say that if it's January and Alaska, then snow. And we use this line here just to make it clear that none of these conclusions are justified without the guard that it's January and Alaska. And that's good. Then we've concluded that January and Alaska means snow, which is pretty much true.